In one of the recent videos, we've talked about an incredible discovery of an intermediate mass black hole that was finally confirmed using data from Hubble telescope after 20 years of observations. And just like a week later, we actually get another study confirming another black hole, an intermediate mass black hole, but this time in a very exciting location where it can actually help us explain how supermassive black holes grow. And so, hello wonderful person, this is Anton. Let's discuss IMBH or intermediate mass black holes once again and talk about these recent exciting discoveries. But I guess first, a super brief definition. So, as the name implies, intermediate mass black hole is much more massive than what you see right here, which is a stellar mass black hole, but much less massive than a supermassive black hole, which we usually find in centers of various galaxies. And normally their mass is somewhere between 100 solar masses and 100,000 solar masses. But exactly how they form is a bit of a mystery. They're extremely unlikely to form from some kind of a supernova, unless it involves a supermassive star of approximately 260 to 300 solar masses, and that's something that astronomers are still not sure about, and most of the environments where signs of these black holes have been discovered usually lack the extreme conditions that lead to formations of such massive, dense objects. But it's possible that they form by combining with smaller black holes, the evidence for which we actually have seen from gravitational wave detections. There was that one detection we discussed previously that produced a black hole approximately 142 solar masses in mass. The video for this should be somewhere in the description. Or maybe they're the result of some kind of a runaway collision of multiple massive stars, all combining into one single object. Nothing like this has ever been seen, but that's one of the potential explanations. Or maybe, just like some supermassive black holes, they were actually created right after the Big Bang, and thus served as a kind of a seed for a lot of objects that very often orbit around them, forming structures like, for example, globular clusters. But the bottom line here is that it's still a bit of a mystery, and there's just not enough evidence to determine exactly how they form. As a matter of fact, up until relatively recently, there wasn't even enough evidence to determine if they actually exist. And it's really only in like the last decade or so that several candidates have been discovered, and something like 10 or so have been officially confirmed. Now, the most exciting candidate was the one confirmed by the gravitational wave detections. That's that video in the description. But on top of this, quite a few objects referred to as ultra-luminous X-ray sources, discovered in various galaxies, for a very long time have now been suspected to be intermediate mass black holes based on their X-ray observations. Here's one of the more famous ones in a galaxy known as ESO 243-49. And quite a few similar objects have been discovered in a lot of different galaxies, including the famous M82. A powerful starburst galaxy that became famous for its iconic images. And so a few star-forming regions in this galaxy seem to contain signs of these intermediate black holes as well. But in order to actually confirm their existence, the researchers have to observe the motion of stars or gas around a central point, or basically conduct what's known as the dynamical mass measurement. And so many of these are still just candidates, they're not actually confirmed. As a matter of fact, as of 2024, nearly 400 such objects have been detected by various X-ray surveys, but only 10 or so are officially confirmed. And one of the most exciting such confirmations in the last few years was from the nearby Andromeda galaxy. Here this was an intermediate black hole, 100,000 solar masses in mass. There should be a video in the description that discusses this in more detail. But basically the way this was confirmed was by observing the motion of stars in this region and discovering that a lot of them move a little bit too fast. And that's usually how we can officially confirm the existence of a black hole somewhere out there. As a matter of fact, that's exactly how Sagittarius A star, the central black hole of our own galaxy, was confirmed as well. And that of course led to the Nobel Prize a few years back. But in the last few years, something else kind of exciting has been discovered in this region that can actually explain a major question in astrophysics: the growth of these supermassive black holes and how they seem to acquire their mass. And that mysterious something is what the scientists currently refer to as HVCC, High Velocity Compact Clouds. Quite a few of these clouds have been discovered in many different locations in the central galactic region, and they've also been discovered in other galaxies, very often near the central black hole. And well, as the name implies, these are extremely compact clouds of gas that seems to be moving really fast. Not like moving left or right, it's basically orbiting something very fast, and something in the middle is obviously keeping it together. And over the last decade, quite a few of these clouds have been discovered in this region, anywhere from several hundred light years away from the center, down to just 1 light year or even less. And while a while back, one of these clouds, approximately 25 light years away from the Sagittarius A star, displayed enough evidence that there was an intermediate mass black hole right in the center, with a mass of about 32,000 solar masses. And back then this was a pretty exciting confirmation. But in this case, the researchers didn't actually think this was the only one. As a matter of fact, a lot of scientists believe that we should find more of these all over the place. Some scientists believe that the image here might resemble something like this. A lot of these black holes everywhere, interacting, colliding, and sometimes combining with Sagittarius A star. And, well, relatively quickly, another such object was confirmed in a different cloud that was even much closer to the center. But one of the most exciting clouds, and the one that showed signs of intermediate mass black hole but was not confirmed yet, is known as IRS-13. And that's the cloud that's super close to the central black hole. As a matter of fact, it's approximately 0.1 light years away from the center of the galaxy, so in some sense you could even say that it's practically touching the central black hole. And so inside of this unusual gas cloud, while searching for clusters of stars, and in the past a lot of such stars have been discovered, the researchers behind the recent study in the description started to find signs of something else. A lot of these stars were moving in unusual patterns, even though technically they should be moving kind of randomly. Not to mention that they were also moving really fast. And in order for these stars to move this way, something in the middle has to hold them together. On top of this, they've also observed X-ray emissions that could only be created by ionized gas rotating at a very fast velocity of several hundred kilometers per second. Or basically, this was the signs of the accretion disk of some kind of a central object. And on top of this, the number of stars and the overall density was unusually high compared to everything else. As a matter of fact, this seems to be the highest density in the entire galaxy, more than any other cluster in the Milky Way. And so, to the researchers behind this study, this was a telltale sign that there is another intermediate mass black hole in here with a total mass of 30,000 solar masses. But because this was so close to the central black hole, this actually provides us with a very important hint. This is potentially how a lot of supermassive black holes became so supermassive, or at least gained additional mass except for basically absorbing gas from the surrounding regions. And so in this case, by having a lot of these intermediate mass black holes in the vicinity, a typical supermassive black hole can potentially grow much faster if it slowly absorbs them over time. And it's possible that for some of the larger supermassive black holes, it just may be absorbed a little bit more. Or at least that's one of the ways they can grow. Naturally, they can also absorb gas from the galaxy itself, but by discovering intermediate mass black holes so close to supermassive black holes, it only hints that they do eventually combine. And so in this case, IRS-13 is definitely going to become some kind of a building block, eventually making Sagittarius A star just a little bit more massive. But naturally, to confirm all of this, the researchers are now proposing additional observations that are going to be able to reveal a lot more detail. Either way though, because we know so many of these clouds exist in the vicinity of the central black hole, it only makes sense to assume that at some point they're going to collide. And it's also quite possible that when these clouds do collide with supermassive black holes, they basically turn these black holes into active galactic nuclei, simply because of the amount of gas and stars present inside of them, and the amount of time it will take this black hole to absorb everything. And so in some sense, those quasars, blazars, and Seyfert galaxies we see everywhere could have been the result of the collision of these high-velocity compact clouds with the central black hole. Or at least that's just the hypothesis for now, because there is no direct evidence yet. But it will probably come eventually. On that note, well, I guess it's pretty cool that another intermediate mass black hole has just been confirmed right here in the Milky Way galaxy, even though a lot of these objects were still mysterious and basically nowhere to be found just a few years back. And so once something else is discovered about these black holes, we'll come back and talk more about this in some of the future videos. Until then, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining a channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.